Section 2, we were talking about number lines and how that can help when you're adding or subtracting real numbers. Now we're going to be multiplying and dividing real numbers. We don't really look at number lines when we're doing that, but real numbers, again, is just really any number you've used so far. So positives, negatives, decimals, which includes fractions, all that type of stuff. So I want to come up with kind of some rules here in this first thing, and really it's going to be this summary we're going to take and take all this mess and kind of summarize it in one thing here. But I wanted to first of all just look at, like, so say you have a positive number times a positive number, and you could pick any number, like let's maybe just say like a 3 times 2. Positive 3 times positive 2 is going to give you a positive 6. So anytime you do a positive times a positive, it's going to give you a positive answer. Same thing if we're doing division, maybe we'll do 8 and 2 this time. So 8 divided by 2, positive 8 and positive 2 gives me a positive 4. So a positive divided by a positive is going to give me a 4. Now these next ones, order doesn't matter when you're doing multiplication. And for signs, order doesn't matter when you're doing division either, just the signs part. But let's say I have a positive times a negative. So positive times a negative, that's going to give me the same answer sign-wise, positive, negative, as if we do that negative number times the positive. So maybe we'll say, how about a 5 times a negative 4? Okay, that gives me a negative 20, which what I was trying to say is that's the same as negative 4 times 5. If we just switch these two around, got excited, forgot my 0. So either way, we're going to get a negative number. So a negative times a positive or a positive times a negative gives me a negative. And we could keep going through and doing this sort of thing with the division and all those. I'm just going to jump ahead a little bit because I'm boring myself. But a positive divided by a negative is going to make a negative. If I have a negative times a negative, maybe we'll actually look at this one a little bit more. But a negative times a negative, maybe we'll say a negative 3 times a negative 2. In your head, hopefully, or maybe on a calculator, you'll say, oh, that's positive 6. So a negative times a negative gives us a positive. And if I were to do a negative divided by a negative, maybe negative 30 divided by a negative 2, that's going to also get me a positive. So positive. So here's the summary. If you look at where we had negative answers, the only places we had negative answers were here, and that's going to be these combinations. So for those, each of those, we have an odd number of negatives. So the summary is if you have an odd number of negatives, that's going to give you a negative answer. So you could go through life kind of learning it that way. That's totally fine. Maybe I should do a clarifier and say when multiplying or dividing. But I'd encourage you to more look at it as though, because for me, if it makes sense, you're going to remember it longer. But if you have a positive times a positive, it gives you a positive. I'd look at it as though negatives can cancel each other out. So positive divided by positive, it's still positive. But when we have this here, we have a positive and one negative, that's going to leave me negative. If I have a positive and another negative, it's going to leave me negative. Or negative and a positive leaves me negative. But negatives can cancel each other. So here if I have a negative, that second negative is going to cancel out the negative and make it positive. Here a negative divided by a negative, these two negatives cancel. And again, leave the answer being a positive number. So want to move on and kind of hit the definition of division. This is going to come up more when you hit a geometry class, but for now we'll touch it. It kind of appears in this section. But 3 divided by 2 is the same as 3 times 1 over 2. So that definition of division is really trying to say, well, if you're dividing by a number, so here I'm dividing by 2, that's the same as multiplying by the reciprocal of that number. And you could even apply that to fractions, like say 3 divided by 2/3. Well, that's going to be the same as 3 times 3 halves. So it's not just 1 over the number, it's saying take what you're dividing by and do the reciprocal of it. Okay, moving on. To multiply fractions, I look at it as though you connect the fraction lines and multiply the numerators and the denominators. So connect the fraction lines Those are actually called verniculums or something like that. But connect the fraction lines and multiply the numerators. So multiply the two top numbers together and the denominators. So you multiply the two denominators together. And we'll see some of that coming up soon. But for this reciprocals, it's two numbers whose product is 1. So just the number 1. So example, and by the way, products, going back to section 1, is multiplying. But if we were to have, say, 2/3, well, the reciprocal of that, we just flip it, is 3/2. So we're taking and flipping that 2/3. Well, product now, if I were to multiply those, what I was trying to say up here, in this section here, by multiplying fractions is, well, we take that, and we connect the fraction line, so I just make it one ginormous fraction. I multiply the numerators, 2 times 3 gives me 6. I multiply the denominators, 3 times 2 gives me 6. And the product we said was supposed to be 1, and it is, because 6 over 6, if you reduce it, you could divide the numerator and denominator both by 6. So divide by 6, you get 1. Divide by 6, you get 1. So the answer is going to be 1. So we talked about inverses in section 2. Inverses are things that undo each other. Reciprocals are multiplicative inverses of each other. So reciprocals are multiplicative inverses. In other words, by that we're saying if you have a number times a number, it gives you 1. So when you have a multiplicative inverse. All right, if we were to have a number divided by a fraction, that's going to be, going back several years now, that's going to be the number. So number, using that hashtags to represent the word number. The number times the reciprocal of the fraction. And something that's messed people up in my classes, at least, is we can reduce fractions, kind of like I was doing up here, reduce that 6 over 6. That's totally fine. It's fine to reduce things kind of in a problem like this, but you can't do it here. You can only reduce the fractions, and I'll write this in red for dramatic emphasis, after changing it to multiplication. So this first one, I have 3 divided by 7 over 9. I found it's a whole lot easier for people if they take and look at this as though, well, 3 is the same as 3 over 1. I probably wouldn't bother writing this step, but I'm going to say 3 over 1 divided by 7 over 9. Well, it's tempting maybe at first glance to say, ooh, look, I can take that 3 and that 9, I can divide them both by 3, so that gives me a 1 and that gives me a 3. Don't do this because it's wrong. What I was just saying up above is you need to change it to multiplication first. So in other words, we have to say, well, I have 3 over 1 times, now I do the reciprocal of my second fraction, and now I can't reduce anymore. So if we know reducing's legal here, in this step, well, then you can't reduce here if you couldn't reduce here. But okay, I move on, I digress. All right, so now when we have this, there's nothing in the numerator, it's nothing in the denominator that can both be divided by the same number other than 1. So we just go through and do the math. Make it one ginormous fraction, multiply the numerators, multiply the denominators, and I get 27 over 7. Typically when we have this, we're going to have you change it to a mixed number. I wouldn't worry about that right now, but this is going to be a 3 6/7. I'll let you get away with this for now. Okay, this next one, I have 4/3 divided by 2/8. We can't reduce here when it's division, so I'm going to slide this up a little bit and say, all right. So I have 4/3 times 8/2. Now I can reduce. And this is a little bit hokey because you could have reduced this fraction kind of right away, but I'm going to reduce this way. I'm going to say, okay, my 4 and my 2, they're both divisible by 2. So divide 4 by 2, I get 2. Divide 2 by 2, I get 1. There's nothing else in the numerator that can cancel with anything in the denominator. So I'm going to actually do that problem. So now I have kind of like one big fraction. 2 times 8 gives me 16. 3 times 1 gives me 3. And because I reduced as much as I could back here, this isn't reducible anymore. Although technically we should change it to a mixed number. So 3 can go into 16 5 times. That gets 15 of my 16 taken away. So I have 1 left of 16. So 5 1/3. And if we move on to page 2 of your note outline, multiplying and dividing with 0. 0 is kind of the strange beast when it comes to multiplication and division. And first we're going to look at what happens when you multiply by 0. Well, let's say I have something different first. Let's say I have 5 times 2. One way that you could look at it is saying that, well, you have 5, so I'm going to put 5 dots on here. If you have that 2 times, well, how many dots do I have? I have 10. So I have 2 multiples of 5, so to speak. Well, if I were to do that with 5 times 0, it'd be saying that I have 5 dots in a row, something like this maybe, but I have it 0 times. So I have nothing, because I have like 0 rows of 5. I have nothing. So any number times 0 is just going to give you 0. The second one, maybe with fractions they used pizzas when I was a kid. I tend to think of pizzas and dividing up pizzas when I look at fractions. And sorry if you're getting this right before lunch. That's just kind of cruel as a teacher. But let's say I have I have a pizza and I cut it into any number of slices. So maybe I have a pizza, I'm going to cut it into 8 slices. That denominator is always how many parts does it take to get the whole. So there's 8 pieces in the whole. If I'm going to give you 0 of the 8 pieces, that gives you nothing. So 0 divided by a number is going to be 0. And it doesn't matter if I have 8 pieces of pizza there. Maybe instead of 8, I have 2. I take the pizza, I cut it in half. If you get 0 of the 2, you still get 0. So 0 divided by a number just is always going to be 0. If we take and flip that around, though, something weird happens. If I take and cut my pizza into 0 pieces, well, you can't do that. The pizza comes out of the oven as one ginormous, awesome, ready-to-eat piece. So it's already 1. You can't cut it into 0. That doesn't make any sense. So kind of like what I wrote over here, cut a pizza into 0 pieces, and I give you 5. So in other words, if we have like 5 divided by 0, well, that doesn't make any sense. I can't give you, you can't divide something by 0. So technically in math then, this here is going to be undefined. Anytime you take a number, even 0 divided by 0, but 7 divided by 0, pi divided by 0, it's going to be undefined. It's not something that physically exists. It's not a mathematical reality. So any number divided by 0 is undefined. All right, we're here at the end. The assignment for my class right there, unless I've told you something different. And in theory, this is what you learned and what you'll be able to do after you're done with all this stuff. Thanks for listening.